Hello, in this video we're finding the domain of a function defined by equation. Let's begin. So we have three problems here. Find the domain of each function of the functions here. So if you notice, the first one is a fraction. The second one is just a simple quadratic equation, and the last one is a rational function. Actually, I should say a function with a radical. So the first one here is x plus 4 over x squared minus 2x minus 3. Now, as in all fractions, you have to be careful because you cannot divide by 0. And when you're finding the domain, that's exactly what you're looking for, is what numbers are allowed to use. Well, since you cannot divide by 0, you have to look at that function and say, okay, what values would not make it defined? Well, of course, when you divide by 0. So the x plus 4 is irrelevant here. It's what the x squared minus 2x minus 3 is. When that expression there, x squared minus 2x minus 3 equals 0, you have a problem. So when you're finding the domain of this function, what you do is you set the denominator equal to 0 and solve it. And then you preclude those numbers from the domain. What that basically means is you assume the domain is all real numbers and exclude anything that makes it 0. So let's look at that. So the denominator can't be 0, so the values where x squared minus 2x minus 3 equals 0. We need to find those values. So if we do that, we factor that out. X minus 3 times x plus 1 equals 0. And so x cannot be 3 and x cannot be negative 1. Now, the set of real numbers is a huge set of numbers. So this function will take anything except those two. So the domain of this set is a rather large set of numbers. It just cannot include those two particular numbers. So if you put 3 back into this function, you'd be dividing by 0, which blows up. So does negative 1. So you cannot divide by 0, so these two numbers are excluded from the domain. Now let's look at part B. Now g of x equals x squared minus 9. There's no fraction here. It's just x squared minus 9. So think of it this way. Can you square a number and subtract 9 from that result and still get a number? Yeah, you can. So if I can square a number, any number you give me, I can square it. Multiply times itself, and I can give you an answer. It may be huge if you want it to be, but it would still be a number. If you want to put 24 in there, 24 squared is 576, and then 576 minus 9. So it's 568. So that is a number. So you can square a number, any number, and subtract 9 from it and get one answer. So you cannot exclude anything from this function. So it's the set of all real numbers is the domain. Now part C, now it's a square root, so it's got a radical involved. And with radicals, you cannot take square root of negative numbers. We've talked about that. So imaginary numbers is not good with the real numbers. So we have to exclude anything that's negative. So the number inside the radical can't be negative. So what does that mean? Well, that means 3 minus 2x. Does anybody remember what that's called? That's called the radicand. So the radicand, which in this case is 3 minus 2x, has to be greater than or equal to 0. Now, greater than or equal to 0 means not negative. So the only non-negatives have real square roots. Non-negatives can't be negative. So 3 minus 2x has to be greater than or equal to 0. And if we solve that for x, now remember when you divide it, you have to divide, it flips the inequality symbol. So you subtract 3 and then divide by negative 2. And what does that become? Less than or equal to 3 halves. So subtract 3 divided by negative 2 is positive 3 halves, but you have to flip the inequality symbol, and so that's less than or equal to 3 halves. So the first one that you're seeing here, less than or equal to 3 halves, that's called set notation. And the second one you're seeing, negative infinity to 3 halves, that's interval notation. And that's my preference right there. Parentheses, negative infinity, comma, 3 halves with a bracket. Now notice the 3 halves has a bracket on it. What does bracket mean? Bracket means you include the endpoint. Parentheses mean you do not include that number on that endpoint. And since negative infinity is not really an endpoint anyway, it always gets parentheses. So 3 halves is where you start, and it said less than, and the key word here is equal to, less than or equal to 3 halves, and it gets a bracket. So anything less than or equal to 1.5. is in the domain. So in other words, if you pick a number like 0, it would work. If you pick a number like 2, it won't work, because 2 is not smaller than 3/2. And whenever you are doing this, you know it's left or right of one number when you have square roots. It's a good thing to do is test a number in that interval and see if that number works. That way you don't make a mistake of picking the wrong side. Sometimes you make a mistake and you put the interval notation backwards. So take a number in that interval. Well, that interval would be like 0, and test it. Do you get an answer? If it doesn't work, then it's probably on the other side. So if I test, for example, 2, which is on the other side, you'll get 3 minus 2 times 2, which is -1, and the square root of -1 is an imaginary number. And so that wouldn't work. So that's a good thing to do, is just test. So once you get the answer on those, test that number in that interval and see if it works. And if it doesn't, then it's probably on the other side of that number. All right, so finding the domain of a function defined by an equation. You start with the domain of the set of real numbers, so you assume it's everything. If the equation has a denominator, which was the first one we had, we exclude any numbers that give a 0 in the denominator. And when the equation has a radical, or with an even index, exclude any numbers that cause the expression inside the radical to be negative. So that's why we make the radicand greater than or equal to 0, and then solve that equation. Sometimes you can do it by observation, but it's probably best just to solve that inequality. Okay, let's look at another example. Finding the domain of an application. All right, a rectangular garden has perimeter 100 feet. Express the area A of the garden as a function of width. Find the domain. So there's a rectangular region, and the width is W. Okay, now the area is W times 50 minus W. Now you're like, why is it, first of all, 50? Well, we'll go with that. We'll come back with that in a second. But notice it's the product of the width and 50 minus W, which appears to be the length, because the area of a rectangle is width times length, or length times width. So W is the width. The length seems to be 50 minus W. And the reason it's 50 minus W is because if the perimeter is 100, then the adjacent sides have to add up to 50. So any two adjacent sides on a rectangle is half the perimeter, because 50 on the adjacent and the other two adjacent are also 50. And so since the width is W, the length is whatever's left, and that's going to be 50 take away W. Now, so now you can forward that out, if you distribute that out if you want to, and get 50W minus W squared, and that would be perfectly fine. Okay, but it also wants to know what the domain is. Now if you look at the area formula right here, W times 50 minus W, then it's almost easier just to kind of do this by just kind of observation here. We know neither the length nor the width can be negative. Okay, we don't have to worry about square roots or anything like that, or fractions or anything else. But this one here is talking about lengths of a rectangle, and lengths cannot be negative. So the width has to be greater than 0. So we already know W has to be greater than 0, because if it was less than 0, then we'd have a negative width. And we also know the length can't be negative. Well, if you look at the 50 minus W, anything bigger than 50 is going to make that length negative. Because let's say if it's 51, it's going to be 50 minus 51, which is a -1, and that's negative. So W has to be positive because of the width, W greater than 0, but it has to be less than 50 because of the length, because anything bigger than 50 would make the length negative. So that defines the domain. The domain has to be between 0 and 50. So that's what W has to be. Anything between 0 and 50. Besides, if two adjacent sides have to add up to 50, then it doesn't make sense. One side is already bigger than 50. So W is between 0 to 50. All right. So that concludes this video. If you have any questions regarding this video or any other questions, please contact me. Have a good day.